Hello everybody. We will be talking now about wiring electric circuits. There are mainly two different ways through which you can wire any element of the electric circuit inside the electric circuit. These two ways are just simply known as series, and the other one is parallel. But before we look into that, let's just look at all the circuit elements that we've learned so far so that we can actually have a better feeling of things. So first of all, this one here that has a zigzag, looks like this, that's known as the resistance in the electric circuit. And this one that has two lines that are parallel to each other, this is called the capacitor of the circuit. We also have this one here that has two terminals like every other element. This one terminal is positive, the other one is negative. This is known as the battery or the voltage. And finally, this one here is basically that's how we represent the battery. If it was like this, if that's the battery, this is the positive and this is the negative, but this is how it is in the electric circuit. So now let's actually look at this one first. So we have a battery here and we have a resistor. So this is a one resistor circuit, as you can see. This is voltage and this is the resistor. And if we look at that, this is the positive side, this is the negative side. Now we know from Ohm's law that V is equal to I times R, okay? Let's try to see how that looks like within a circuit like this, a simple circuit that has one loop, all right? So the way we do that, first of all, if you start at a point A, okay, you know if you go around on a point A and you measure the voltage difference of point A at point A, you know that the voltage difference, delta V, at the same point for any instrument, you know that it should be equal to 0 because there is no voltage difference on the same point, and that makes sense. So now from this we can actually start studying circuits better. So if you go around, so they say if you go around a circuit like this, start from a point and you come back to the same point, you can say that summation over voltages that you come across when you go through around the circuit, all these voltages must add up to 0. Okay, now let's see how that goes. All right, so let's start from this point. There is nothing here, so we're adding all the voltages now. We're applying this equation. Let's start from this point. Go, 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 go. There's nothing here. You face the battery, so you face the negative side of the battery and you go to the positive side. So from the negative to the positive, it's like you are gaining a voltage. And what's the value of that voltage? It's the value of the battery. So that's the first voltage we have. It's a positive voltage. Now you know that the current is going to be pushed this way. So that's I. So the current. And since the current is going this way, it's going to keep going the same direction all the way till it comes back to the battery. Okay, since the current is known to be going from this side of the resistor to this side, then this side must be at a higher potential than this one. So we call the first one is positive, the second one is negative. All right, so let's go here. We found out the first voltage was the battery. Now we continue, go, 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 go. Okay, you face the positive side of the battery, and now you go through it to the negative side. So it's kind of like you have lost some voltage because of that. From the positive to the negative, you have lost some voltage. And how much is that voltage? It is actually equals the current that passes through it times R. So I'm going to say, since you lost, I'm going to say minus IR. Now go back, keep going on the wire until you hit A. Once you hit A, you may say this is equal to what? 0, because you go back to the same voltage. So here that tells us that V of this circuit is equal to IR, which means that all the voltage here is equal to the voltage through the resistor because we only have one resistor. All right. Now let's upgrade. Look, we still haven't talked about wiring resistors in series. Now, how do we wire two resistors here in series? Okay, so you bring another resistor and you paste it basically to this circuit, or just like what I did here. So I have here a circuit just like the ones that we talked about before. We have a voltage battery here, voltage, and we have a resistor here, R, and we have another resistor here, R. Since these two resistors may be different, so I'm going to call this R1, I'm going to call this R2. Notice that the two resistors are connected only with one wire, as you can see. It's like a pipe. That a pipe, like a fluid goes through the pipe. It's one pipe, one whole pipe in the whole circuit. So basically, the current, as we know, will go from the positive to the negative. So I'm going to call this I. We only have one current since we have only one pipe. And the current is going to go through this way because that's what the battery is going to do. It's going to push it from the positive to the negative. Since it's going from here to here, so this will be positive and negative. And again, here will be positive, negative. And the reason is just because, again, the current continues its motion through R2 from the higher potential to the lower potential all the way till it comes back. So now we need to find what the resistors equivalent if these two are connected on series. And this is how we connect them on series. As you can see, is like they're behind each other or following each other. Okay, I'm going to call this point A. I'm going to say summation over all the voltage on a closed circuit must equal to 0. And now I'm going to go this way. Okay, I'm facing the negative, going to the positive, so I'm gaining voltage. So how much is that? It's V, the voltage of the battery. Keep going, keep going, keep going. Okay, I'm going to the positive, going to the negative, from positive to negative, so I'm losing voltages. So this will be minus IR1, according to Ohm's law, minus IR1. Keep going here, from the positive to negative, another minus. So I'm going to say minus I, the same current going through it, but this is resistance R2. And now keep going. Once you hit A again, you make it equal to 0. And that's it. Then this here, V, is equal to, take it to the other side, I R1 plus I R2. And that's it for now. But this V, the voltage, is the voltage of the battery. So it has the current I and the resistance of the whole circuit. So we can call this I times the resistance of the whole circuit. They call it R equivalent. Okay, and that should be equal to I R1 plus I R2. Divide by I with I goes away. Then R equivalent is equal to R1 plus R2. So basically, this equation tells us that if you connect two resistors on series, the total resistor value is going to be added algebraically to each other. So R1 plus R2, okay? That's R equivalent. Now, what if we have another resistor that is connected on series? You have R1 plus R2 plus R3, 4, R1 plus R2 plus R3 plus R4, until n number of resistors. Okay, notice that R equivalent here is bigger than the biggest resistor here. If this was 3 ohm and this was 7 ohm, then R equivalent is 10, which is bigger than the biggest resistor of the two. And remember this because that will help you in solving complicated problems. Now let's go to resistors on parallel. This is how in parallel looks like. So it looks like two columns or two rows under each other, if you will. Okay, so I'm going to call this V for the voltage of the battery. I'm going to call this R1. I'm going to call this R2. And the question is, we need to find the value of the equivalent resistor of these two resistors when they are connected on parallel. Okay, one thing you should remember, that when you have two things connected on parallel, that there is a fork, as you can see. So there is like what we call a junction. Okay, this junction here, you have to pay attention that the current comes like this. So this is the current pushed by the battery, goes up like that, and the current now sees two ways to go. Okay, now it's gonna go both ways, or it's gonna split itself. Basically, it's gonna split itself depending on what the value of each resistor. If this resistor is very high, then a small current will go through this one, while most of it will go through this one, and vice versa. So we don't know what's going to happen. Basically, what I will do is I will actually call this I1 because we don't know its value, and we will call this one here, the current here, I'm going to call this one I2. Okay, so what's going through here is I2, this is I2, and this is I2. This here is I1, and once they gonna get together here, they're gonna meet and they're gonna form what? I again. And here it's gonna be I again. Okay, so that's what's actually gonna happen in the circuit. All right, now we know that I is equal to I1 plus I2. Okay, I, which is the current according to Ohm's law, is equal to, you know, Ohm's law, V says V equals IR, then I is equal to V over R. So this V over R must be equal to, now something you should know also about connecting two things on parallel. If this is the voltage of the battery, the voltage across this is actually the same as the voltage of the battery, and the voltage across this element is the same as the voltage of the battery. Okay, because all of them, as you can see, in the same kind of like rows. So this is row number 1, row number 2, row number 3, if you will. So row number 1 has a voltage of the battery, which is V. Then row number 2 must have the same voltage. Row number 3 must have the same voltage as well. Okay, so I1 now is going to be equal to V of the across that resistor, right, divided by what? R1. Plus, now I2, because I2 is here, is going to be equal to V divided also by R2. Now divide this whole equation by V, so you end up 1 over R, and I'm going to call this R equivalent because that's the total resistor, must equal to 1 over R1 plus 1 over R2. And this is the R equivalence of two resistors connected on parallel. If there is 3 resistors, you are going to have to say 1 over R1 plus 1 over R2 plus 1 over R3. And the same if there is a 4th. Okay, now notice something. If this resistor, for example, is equal to 4 and this resistance is equal to 2, let's just use this as a demo example. So R1, so this would be 1 over 4 plus 1 over 2 for this one. So basically I will just make the denominator common. So this would be 1 over 2 is actually 2 over 4, if you will. 1 plus 2 is 3, so this whole thing is 3 over 4. But remember, this is 1 over R equivalent, not R equivalent. So this is equal to 1 over R equivalent. And a lot of people make this mistake and they forget to actually take the reciprocal of this. So if they want to get the right answer, so R equivalent should be equal to 4 over 3 ohm. Notice something else here, that R equivalent 4 over 3, which is a little bit more than 1 but less than 2, is smaller than the smaller resistor, which is 2. So remember what we learned for the resistors in series. If 2 resistors are connected in series, R equivalent for them is bigger than the biggest one, and if they are connected in parallel, R equivalent for them is smaller than the smallest one. And that's how we connect resistors on series R and on parallel. All right? Thank you.